Hello class, today we're going to work on problem number 2 in your partial fraction decomposition practice set. And problem number 2, the first thing we want to do is check to make sure the degree of the numerator is less than the denominator. Here we see the numerator is degree 1, the denominator is degree 2, so we do not have to perform long division and we are good to start the problem. The first thing I want to do is factor the denominator. So the denominator factors into two binomials, and I believe those two binomials are, 5t minus 1 times the quantity 2t plus 3. And if you're not sure, let's just quick double check. Let's distribute, right? 5t times 2t is 10t squared. 5t times 3 is 15t. This is negative 1 times 2t is negative 2t. That gives me 13t. Negative 1 times 3 is negative 3. And in this problem, we have degree 1 over degree 2. And it will be the same setup as problem 1. Recall problem 1 I have here, which is degree 0 over degree 2. So degree 0 over degree 2, degree 1 over degree 2 get the exact same setup, which is we are going to put it over a over the first factor plus b over the second factor. Okay, now we're going to proceed in a similar fashion to the other problem. The first thing we're going to do is add these two fractions. And if you're good at adding fractions, you could probably skip right to the following step. If you understand that they're both going to have a common denominator, you could probably figure out that we have a times the quantity 2t, oops, that's a 3, I'm sorry. Good thing I caught that. That would have been bad. A 2t plus 3 plus b times the quantity 5t minus 1 all over the quantity 5t minus 1 times 2t plus 3. Okay, so I encourage you to pause the video if you have any questions at all how this works. You're going to multiply essentially the first fraction by the fancy one of 2t plus 3 over 2t plus 3, the second fraction by the fancy one of 5t minus 1 over 5t minus 1. And now you'll see we have our proportion. I have one fraction equal to another fraction. The denominators are equal, so that means the numerators are equal. So I can say that 8 minus 3t equals a times 2t plus 3 plus b times 5t minus 1. Now, we need to make sure that we are not using any decimals or a calculator. You're going to need to not use a calculator in calculus for these type of problems. So we're going to practice just using fractions. So the strategy is still the same. I want to pick a value for t, right? T is a variable, it's unknown. I want to pick a value for t that allows me to solve for a or b. So in this case, I'm going to let t equal 1/5. Now, why am I doing that? Well, if I let t equal 1/5, it will cancel out the b. So I'm going to say that 8 minus 3 times 1/5 equals a times 2 times 1/5 plus 3 plus b times 5 times 1/5 minus 1. Okay, now let's just do some fraction work here. This is going to be 8 minus 3 over 5 equals, now this will be 2/5, but 2/5, I don't want to add that to 3 over 1. I'm going to call 3 15/5, right? That's the same thing as 3, and that's going to be 17/5. So this is going to be 17/5 a, and I know that that's going to add to 0. That's why I picked 1/5. Now again, with the 8, I'm going to call the 8 40 over 5. That's a better name for the number 8. And again, I'm not using any calculator. This is going to be 37 over 5 equals 17 over 5 times A. Now, to solve for A, probably the easiest thing to do would be to multiply both sides by 5 over 17. Why is that a good idea? Well, cross simplification gets A by itself. Cross simplification gets 37 over 17. I know that's a weird answer. This is pre-calculus, so that is perfectly fine. So A is 37 over 17. Now we're going to do the same thing to solve for B. Okay, again, we're going to let T equal something super easy. So what should we do? Let's see. If we want to get rid of A, we should let T equal negative 2/3. That'll cancel out the A. So let T equal negative 2/3, or sorry, sorry, negative 3/2. I can't think. Negative 3/2. That's what I want. That's going to get rid of the A value. All right, so let's plug that in. So I have 8 minus 3 times negative 3/2 equals, now I know if I plug that in for A, it cancels, right? So I'm just not even going to write it this time. I think I'm just going to omit that if you understand that that's just going to make A go to 0. Plus B times 5 times negative 3/2 minus 1. Okay, so let's continue our fraction work. Let's make sure we can simplify. This is going to be 8 plus 9 over 2 equals B times negative 15 over 2, and I'm going to call this negative 2 over 2. That's a better name for the negative 1. Instead of the 8, I'm going to call that 16 over 2 plus 9 over 2 equals negative 17 over 2 times B. Adding these together gives me 25 over 2 equals negative 17 over 2 times B. To get B by itself, I'm going to multiply by negative 2 over 17. Cross simplifying gets me B equals negative 25 over 17. So we now know the values for A and B, and we can finally state that in our original problem, 8 minus 3t over 5t minus 1 times 2t plus 3 equals 37 over 17 over 5t minus 1 minus 25 over 17 over 2t plus 3. And again, some keep change flip. You know that's 37 over 17 times 5t minus 1 minus 25 over 17 times 2t plus 3. And that would be my fraction decomposed into linear parts.